Assalamualaikum. My name is Nurul Arifah binti Sharobari. My metric number is CD200065. I'm going to present about the abstract of this project. The purpose of this project is to design an important part of aeronautic component. Our group have chosen to design an aircraft expanded tube for this task. The expanded tube brake is used on some type of support equipment. The technical manual frequently refer to this brake as the aircraft type expanded tube brake because the expanded tube brake was originally designed for aircraft. The methodology of this report is we make a research through the internet to get some info about the expanded tube. For the design, we apply all the methods that we have studied in this semester to design the final product. In this report, we have included isometric drawing, orthographic view, exploded drawing, assembly drawing with suitable tolerance or other engineering assembly standard code and bill of material. So let's move to the introduction. Very early, aircraft have no brake system to slow and stop the aircraft while it is on the ground. Instead, they rely on the slow speed, soft airfield surface, and the friction developed by tail skis to reduce speed during ground operation. Brake system designed for aircraft became common after World War I as the speed and complexity of aircraft increased and the use of smooth, paved runway surface proliferated. All modern aircraft are equipped with brakes. The proper functioning is relied upon of safe operation of the aircraft on the ground. An expanded tube brake is different approach to braking that is used on aircraft of all sizes produced in 1930 to 1950. It is lightweight, low-pressure brake ball to axe a flank that fit inside an iron brake drum. A flat fabric reference neoprene tube is fitted around the circumference of the wheel like top flank. The exposed flat surface of the expanded tube is lined with brake blocks similar to brake lining material. Two flat frame bolt to the side of the top flank. Tabs on the frame contain the tube and allow evenly spaced torque bar to be bolted in place across the tube between each brake blocks. This prevents circumferential movement of tube on the flank. The expanded tube is fitted with a metal nozzle on the inner surface. Hydraulic fluid under pressure is directed through this fitting into the inside of the tube when the brakes are applied. The tube expands outward and the brake blocks make contact with the wheel drum causing friction that slows the wheel. As hydraulic pressure is increased, greater friction develops.
Assalamualaikum, my name is Nakiuddin Azan Husna bin Zunaidi. Objective for this report is first to investigate and analyze the shape and size of the brake system before and after assembly. Second is to determine the dimension for each part.
Assalamualaikum and hi everyone, my name is Muhammad Aiman bin Nordin. Today I will review about expanded tube brake. As you see here, this is the expanded tube brake, the image of it. This brake made by four major components which are top flange, expander block and toe frame. And other components are top bar bolt, brake frame bolt and adjuster, as you can see from the picture before. Internal components are brake block, return spring, tube shield, nozzle and return spring shield. So let's review from its function. Its function as drum brake. Through a nozzle, it using a hydraulic liquid to inflate the rubber tube in the expanded tube brake and cause the brake block in contact with the rotating part of the aircraft wheel, which then produce friction that slow down the aircraft movement when brake. There are few brake blocks which increase the friction, which are important in converting kinetic energy into heat energy to slow the aircraft movement. So that means the more the brake block, the more friction is produced. So the easy is the aircraft to get slowed down. When the pilot releases the brake, the return spring will make the brake block to the initial position. So that is the review from its function. Review from its disadvantage. I found that there is two disadvantages. First, when action in cold weather, the brake will not function at optimal condition. Second, when act in high temperature, they prone or expand to swell and leak, then drag, which make friction inside the drum after the brakes are released. So as we know, metal expand when get heated. So this brake block will expand a bit. That's cause the inside expanded tube brake produce a frictions. So even the brake is released, there is still a frictions. Cause the aircraft not movement, which cause the movement of the aircraft is not smooth. So that's all the review from me. Thank you.
Okay, Assalamualaikum. My name is Muhammad Akil bin Matnawi. My matrix number is CD200037. So today I would like to tell about the brake actuation system for the expanded tube brake. Expanded tube brake make type use of hydraulic system to actuate the brake pad onto the disc or drum. The hydraulic system that provides this actuation differs depending on the size and complexity of the aircraft. There are three different systems to describe and cover the majority of brake actuation systems in use today. Okay, first, independent brake system. Like aircraft with a hydraulic system to actuate flaps, control surface or landing gear make use of an independent hydraulic system to actuate the brakes. This stand-alone system consists of a reservoir master cylinder connected to a brake pedal and a piston in the brake caliper that actuates to apply the braking force. When the pilot applies the brake pedal, the hydraulic fluid in the master cylinder is forced through the hydraulic lines to actuate the piston in the caliper. This pushes the pads onto disc or drum, creating the friction necessary to slow the aircraft. Second, booster brake system. An independent braking system does not make use of an mechanical pump to augment the pressure applied by the pilot by operating the brake. An aircraft fitted with the hydraulic system can boost the brake pressure by tapping the hydraulic system into the brake system. The hydraulic boost is only used under heavy braking and can increase the brake pressure to a value greater than that which can be applied by the pilot alone. The brake system are used on larger aircraft that require augmentation of the manual hydraulic braking system to slow the aircraft in a reasonable system. And the third one, power brake system. Power braking system are used on a large aircraft where a manual or boosted system is insufficient to develop the hydraulic pressure required to arrest the aircraft. This system use the aircraft hydraulic system as the sole source to apply the brakes. The pilot is control the brakes through the toe brake on the rudder pedals. But the force produced is no longer a function of the strength of the pilot. Applying the brake opens a valve that allows fluid from the hydraulic system to enter the brake lines. The rate at which hydraulic fluid flows into the brake lines is regulated by the valve and is designed to give the pilot a feel for braking action that is proportional to the force exerted on the brake pedal. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. So my name is Muhammad Afif bin Harizan and my metric number is CD200115. So as you guys heard just now, my friend already talked about the introduction, about the objective, and about the product review of our project report. So the product is expanded tube brake. So yeah, so it's my turn now to explain about the drawing that we drew for the manual drafting subject. So this is the assembly part of the expanded tube brake. As you can see, we managed to lower the size of the expanded tube of the original expanded tube brake by the scale of the scale ratio of 1:3.5. So the original scale is quite big, so we need to lower the size so that it can fit into the drawing paper, which is the A3 paper. So as you can see, this is the drawing assembly part of the expanded tube size. So next, this is the explode view of the expanded tube brake. There are a few parts in this section, which is the frame, the top flange, and the expanded tube itself. So the first picture is frame. As you can see, this is the view of orthographic, and next this is the view of the isometric. Okay, so next this is the top flange, the orthographic view, and next is the isometric. And also the last picture is expanded tube, and this is the orthographic, and next is the isometric. I said just now it has 4 parts, but I only say 3 because the frame, there are 2 frames in the expanded tube brake. So in the assembly part, we combine the frame. One frame is at the front and the other frame is at the back. So that's all from me. Thank you.
Conclusion: manufacture an aircraft braking system is very complex as it requires combination of suitable material and part before assemble it to become brake system. We have successfully completed the drafting of the aircraft braking system, which are divided by 4 parts. Every part has a different shape and uses that completing each other. The brake system also can avoid the aircraft from accident and save invaluable human life. The intelligence of the engineering in developing the technology of the brake system give substantial benefit to aircraft industry nowadays.